Good morning, everyone. It is my real privilege to be here today. I've actually been in Australia for about 10 days, because you guys are so far away, traveling the country with my family. So I've been seeing, just again, witnessing that welcome to country ceremony this morning. Again, just imparts what I've been feeling here, the connection, past, present, and future. So it's a very special place. Thank you for having me. As you can see, I'm wearing my Australia dress. But today, I am going to be talking to you guys about artificial intelligence, because it is my view that we are at a profound tipping point in human evolution because of the way that intelligence is soon going to be imbued by machines, and how profound this will be for the way that we live, for the way that we work, even for the way that we produce food. So I think we are entering the dawn of a new age. I call it the age of AI. And I was just briefed backstage that AI means artificial insemination to a lot of this audience. So no, we are not talking about artificial insemination. What we are talking about can be summed up pretty neatly by Sundar Pichai, the CEO of Google. Let's have a listen.
AI, generative AI, AI is AI. It uses AI to bring AI.
The end of my keynote speech. Bye. It's good that I got the brief on artificial insemination, right, before I played that video. But yeah, I mean, AI, it's been everywhere. It's on every agenda. Everyone's talking about it in the boardroom. You're talking about it across the dinner table. So what I want to do today is give you guys a little bit of a foundational conception, because I want you to have the right mindset to think about how to navigate the age of AI. So what we're going to do is talk a little bit about what it is, how it can do what it's doing, and why you should care, and why this really matters to agriculture as well. So we're going to do those three things. So what is AI anyway? It is, starting from first principles, it's always been the pursuit of, can we imbue machines with intelligence? Right? Intelligence is the trait that has always distinguished us as a species. So is it arrogant to assume that intelligence can only be imbued by biological creatures, right? So since the 1940s, since the birth of modern computing, modern computers, there's always been this pursuit of, can we make machines intelligent? And is there some point where actually machines will be just as capable as humans across general intelligence, and actually become even more intelligent than humans? So the philosophical question at the heart of artificial intelligence has always been this: can machines think? Now, to test that, the legendary kind of pioneer of modern computing, Alan Turing, devised a test known as the Turing test, right? And he basically posited that when we get to the point where you have a person talking to a computer, and that person is convinced that they're talking to a human rather than a computer, this is the so-called imitation game, then we know that machines can think, right? And part of the hype about AI, especially over the past 12 to 24 months, is that all of a sudden, its increasing capabilities have led us to think, okay, well, the Turing test is kind of beat now. We can be convinced that when we look at something that AI says or does, that actually it's not a machine, it's a human. And to test that, let's watch this video.
Hello, Evoke. I am Nina AI, Nina's AI-generated avatar. AI helped distill Nina's biometric data, so I could look and sound just like her.
I can actually sound like anyone. How's my Aussie accent? And how's that for beating the Turing test?
Good Aussie accent? Crazy, right? This is an AI-generated video, which I made in about 20 seconds using a generative AI video platform. Again, none of this was possible even 4 or 5 years ago. Now this is a kind of platform and a software which is used by the majority, 70% of the Fortune 500 company for internal communication videos. So again, showing you how AI's capabilities have been accelerating over the past few years, where it's really getting to the stage where we're beginning to wonder, is this on par with human creativity and human intelligence? So really, when we start thinking about AI, the fundamental thing to keep in mind is that what we are now starting to see is the beginning, the birth of a new infrastructure for intelligence, where you are going to have machines that are able, and again, if your definition of intelligence is simply the ability to process lots of information, to make decisions, to be creative. Well, this is kind of the new dawn where machines are going to be able to augment almost any human creative or intelligent endeavor. This infrastructure of intelligence is now being built, which is going to be woven into the ecosystem, the digital ecosystem, which we currently already exist in. But so much about the debate on AI is super distorted, because so much of it focuses on AGI, artificial general intelligence. Just by show of hands, who's heard of AGI? So yeah, most of you have. So this is the concept, the idea of when we will reach the point where machines are just as intelligent as humans and can maybe take over the world and be very, very dangerous, the blinky kind of robot, right? So much of the debate around AI is, A, that it's dangerous, it's gonna take over the world, it's gonna kill us, or actually the naysayers who think, okay, well, that's never gonna happen, they are not really intelligent anyway, these are just machines that are regurgitating what's been put into them, they're actually stupid and we're never gonna get to AGI. But I posit something different. Long before we get to AGI, which is a philosophically really interesting question, we can spend lots of time debating about when that might be and how long it will take, but long before that, we are already starting to see the emergence of artificial capable intelligence, ACI rather than AGI, these systems that are being woven into the fabric of life that are, like I said, already transforming how we work and how we live. It doesn't mean they're sentient or can think like humans can think, but they're definitely already having an impact. We're going to start to get into that. So, how? And I think part of one of the biggest misconceptions around artificial intelligence is our propensity to talk about AI as though it's a single technology. Right? AI technology. And it's not. It's a meta technology. It's a general technology that enables other technologies. And in this case, like I said, it is actually the meta technology for processing information. Again, the meta technology for intelligence itself. The best analogy is actually computing. Right? The birth of modern computing started in the 1940s, which has led to other technologies like the internet, smartphone, cloud, the age of information, the digital era. So again, if you start thinking about how does AI impact agriculture? How does AI impact my crop yield? How can it be how could I use AI to monitor the livestock, the health of my livestock? Where can AI be implemented? What are the applications? The answer, just like digitalization has impacted modern agriculture, is that it can impact everything. Right? It's this meta technology that can be applied across industries, across different use cases. And the reason we can do this is, well, due to 3 foundational pillars. The first is the birth of modern computing, right? And here basically, the ability for computers to churn through information has been on an exponential curve. According to Moore's law from 1965, the computing power of machines would double every year. And what we've actually seen is that it's been far more profound than that. So this is one of the first foundational pillars of machine intelligence. It's the improving computing ability of machines. The second, which is super fundamental to AI's application in agriculture or in any, actually, industry, is data, right? Data is the fuel for artificial intelligence. Without data, we can't have any AI. This is the input, the information that is needed to have those kind of interesting, magical applications for intelligence. And already, we produce vast quantities of data. Living in this digital ecosystem, 3.5 quintillion bytes of data daily. That's a big number. Lots of zeros there behind the 3. And already in your practices as agricultural producers and farmers, you would already be working with digital solutions and platforms and data, right? So that trend is going to continue, and that data is going to become even more valuable for actionable insights. So it's computing power, data, and finally, deep learning. This is the model of a new architecture of artificial intelligence, which has kind of been developed over the last 10 years, which is loosely modeled on the architecture of neural networks in our brain. Again, if the idea is, can machines learn? Can machines think? Can they become intelligent? Why not structure the architecture of these systems on the human brain? And this is where we've seen some of the huge breakthroughs in artificial intelligence emerge over the past decade. It's with this deep learning architecture. And one of the fascinating things about deep learning is that for the first time, we've actually developed a technology which is kind of black box. Just like we don't fully understand how the human brain works, we don't fully understand how AI systems work either. We don't really understand how when we put all the input in, it gets from A to Z, okay? So this is kind of a black box system, loosely modeled on the human brain. But I think the real moment of aha on AI for the world came in November 2023. You'll all probably know this because you either spoke to your child about it because they were using it to do their homework, or you spoke to your colleagues about it. It was the release of ChatGPT, right? That was in November 2023, which again was just this wake-up moment for the whole world, thinking again about the Turing test and AI's emerging capabilities, where we suddenly realized, wait a minute, now this isn't really in the realm of the theoretical anymore. These capabilities can be applied in practical, real-life situations. And what you need to know about ChatGPT and why the so-called large language model, the type of model that ChatGPT is built on, is so important is because over the past 12 to 24 months, we've seen the rise of so-called foundational models in AI. Now, these models are basically going to become the platform that we all plug into to make use of AI for our own specific use cases and for our own specific applications. Now, these models are very interesting because they are trained on vast data sets. So some of the early foundational models, like GPT-4, is basically trained on all the text that exists. You might have seen some of the kind of image generators, like Midjourney and Stable Diffusions, which are able to generate images. But the other really interesting thing about these foundational models is they're inherently general purpose, meaning that with minimal fine-tuning, you can apply this platform, this infrastructure, to do a multitude of human intelligent or creative tasks. And these models are all built with a layer of so-called NLP. Now, that's natural language processing. The reason why that's important is because now, all of a sudden, we have the ability to speak to AI systems and AI models in human language. Right? You don't need to be a coder to deal with AI anymore. You can simply instruct with text what you want one of these models to do. I'll give you an example. So Sora just came out about 3-4 days ago. It's the latest foundational model from OpenAI, trained on vast amounts of information and data, and it can generate videos, right? So when you give this prompt in human language to Sora, a gorgeously rendered papercraft world of a coral reef, very appropriate for Australia, rife with colorful fish and sea creatures, here is what it can actually create, generate. Right? This is a piece of content that did not exist before, that was simply able to produce based on its understanding of the data and then the human language prompt. So again, if you start thinking about this foundational model, this platform, and how you can apply it into almost any human industry, including architecture, we're still very early days, but what we're heading towards is models that are primed for architectural practice because they are trained on agricultural data that you can simply prompt to get the insights that you need. Because, as I already mentioned, AI speaks human. It has this ability to understand what we want because it's built with this layer of natural human processing. So it's really also important to understand when you start thinking about how inevitable AI is going to be in terms of how it's already being rolled out. All of us are going to use it, right, if you're not already using it. But where does the infrastructure sit and who owns it? This is pretty much the tech stack, right? Who owns this core infrastructure? And at the bottom layer, you have the computing powers, right? Everybody needs access to the GPUs, to the chips, to be able to process all this information. That is the fundamental infrastructure layer for the AI revolution. The second layer that's being built for the stack is the foundational models. These are those huge, huge models that I was talking about that can be fine-tuned for any purpose across multiple industries where data is going to be the key to optimize it for your specific use case. But again, those models are being built by a few players who we're going to get to. And then finally is the application layer. And that's the layer where you're going to see lots of different companies, lots of different use cases where everybody can plug in and build their own ideas or their use cases or their companies. But the tech stack, the most value is coming from the infrastructure and the platform. And what's really interesting about who owns that is that it tends to be a few massive tech giants, right? One of them is NVIDIA, which has an 80% monopoly on the chips, 80% monopoly on the GPUs that are required to compute all this information and data, which is why you can see how NVIDIA's stock price has been going up exponentially. I hope there's some of you in the audience who hold NVIDIA stock. And then on the actual platform layer, and these companies are the companies you guys are going to be collaborating with, everyone's going to be collaborating, it's the big tech giants, right? Microsoft, Google, Amazon, Meta, Apple, they are building that platform which we're all going to plug into to optimize AI for our own specific use cases. Of course, you also have some of the Chinese tech giants building this platform, but it is undoubtedly the big US tech giants who are partnering with some of the frontier AI companies like OpenAI, for instance, to bring these capabilities to you. And when you think about these capabilities, actually, they're already here. It isn't that you're going to have a moment where you're like, now I am an AI-first company, and before I didn't use AI, we already are using it, because it's basically coming to all of us already simply as a hardware update and a software update. And we're going to talk about that in the context of agriculture. So what might that look like? So for instance, Thinking about AI in agricultural practice, maybe counterintuitive, but Microsoft is going to be one of the biggest innovators of change for AI in agriculture. Why? Because already for a couple of years, it's been gathering lots and lots of data, which is relevant to agricultural practices, from satellite imagery to weather data, to data which can come from sensors in the crop. And it has been building a platform, talking about that foundational platform, right, called Microsoft Data Azure for agriculture. So it's got all this foundational information and data, which is, again, this foundational platform, this model, which is going to be so relevant to agriculture, the agriculture industry and food producers. And then it's partnering up with other kind of giants in the space to use that data to bring value to food producers. So for instance, Microsoft has been partnering with Bayer, and Bayer has been using Microsoft's historic huge amounts of data on satellite imagery, weather patterns, to improve crop yields and to also understand where there might be potential vulnerabilities with the yield. And now, because Bayer is obviously such an important player in this space as well, it's using that platform, integrating its own data and institutional knowledge, so they kind of have a data sharing model to package up into an enterprise software solution for its enterprise clients, right? To help them improve the crop yield, to monitor the soil health, and to be more efficient and productive. And the same kind of model is working, which I found really interesting, Microsoft is doing with Land O'Lakes, but on sustainability. So working with Land O'Lakes with vast amounts of sustainability data, focusing on how agricultural practices are impacting the levels of nitrogen in the earth, the level of water, and actually helping farmers using kind of the products that are being developed as a software solution between Land O'Lakes and Microsoft to tell a better story about sustainable practice with actually real quantifiable data. So not only helping farmers adopt more sustainable practices, but also to communicate that story, which we know is increasingly important, to their investors and to consumers, right? So this is one example of how AI is just coming as a software update to whatever platforms you already use. But again, if you track it back far enough, I'm sure at some point you'll come back to one of the big tech giants, because again, they're the ones building that core infrastructure for computation and also for the platform, right? Which is why well done you if you hold Microsoft or NVIDIA stock. Another example of how this is coming as a hardware update is through just updated machinery, right? And this actually predates some of the advances in generative AI, but John Deere, which is obviously a producer of agricultural machinery, announced already at CES in 2022 their plans for an autonomous tractor. And the really fascinating thing about this tractor is that it has a see and spray system, which is essentially a system equipped with machine learning and computer vision. And computer vision is basically the ability for computers to compute what it sees. So computer vision and machine learning so that it's really effective at spraying herbicides, right? So precision farming, being really effective at spraying the herbicides. And John Deere expects that this tractor system, which is still in development, and again, they've been really looking into investing in data and AI systems for a good 2 decades, but this system will be fully autonomous and operative by 2030 to help farmers not only with precision agriculture, but also to deal with some of the problems we have around labor shortages. So again, coming to you as a hardware and software update with the companies and the machinery and the platforms you already use, right? We see here, and this again is almost even prior to some of the most recent advances and capabilities with artificial intelligence, but some of the main 5 use cases of AI and robotics, so kind of the software and the hardware in agriculture. So analyzing satellite images, in-field monitoring, assessing the crop and soil health, agricultural robots, like we just saw with the autonomous tractor, and predictive analytics. So basically going forward, I mean, as all this data is compiled and packaged up in software and for platforms that you already access, and we see the use of more robots, it should become easier to do your job better, in part because you have access to all this vast amounts of data that would have been siloed otherwise, right? That you wouldn't have necessarily had access to. Just out of interest, does anybody in the audience use any of these? Any hands? Sorry? Yeah, well, these are the old guys, right? So, well, great. So Australia is leading the way then on innovation. So coming back to first principles and asking again about the Turing test and the pursuit of intelligence itself. I said that lots of people are concerned about AGI and the robots taking over and basically losing control of autonomous systems, but that I actually foresee a situation where we're going to have very capable, intelligent systems that are implemented into almost any human creative or intelligent endeavor across industries. So it makes sense for us to have a Turing test for our times. It isn't, can you talk to a machine and think it's human? Because we've already kind of passed that, right? We need a better test for capable intelligence. And one of the new tests that's been proposed is that we connect it to the thing that literally is the currency of value in our society, that is money. And the new Turing test should be, can we instruct AI to basically make $1 million, right? Be like, here is a $100,000 investment. Can you convert this into $1 million over 6 months? And some of the kind of frontier AI researchers and philosophers think that ability for machines to be able to do something like this, right now we're seeing the capabilities are still fairly narrow, is something we'll be able to do in 3 to 5 years. So similarly, you can imagine how even in agriculture, you can use that capability to find out, how do I improve my crop yield by 30%? What should I be doing to improve my sustainability practices? What am I not seeing in the data that is going to be really vitally important for me? So that is the benchmark for the new Turing test of our time. And like I said, AI researchers think we're going to be there in 3 to 5 years. Now, final point to make is that we are living in an era of exponential change, right? Throughout history, we have encountered general technologies that have transformed the society and then the world. But now those general waves of meta-technology are coming faster and faster and faster, right? So from the invention of fire to the first agricultural revolution to the industrial revolution, then now we get to the 1940s with computing, and suddenly we are at the age of AI. Those exponential technologies are coming faster and faster and faster. But one thing that is so fascinating about general technologies, as history shows us, is that you can't avoid them, right? The rule is endless proliferation. And that is certainly true for artificial intelligence, in my view. If you look at the adoption curve, it's already faster than any other technology we have encountered. And one of the other very interesting things about general technologies is that they're not simply products for us to use or tools for us to use. We become products of these technologies too, because they change us on a biological, even anatomical level. Consider, for instance, the invention of fire, how it changed how we organized our societies. It transformed our digestive tract. And I don't need to tell you about what the invention of agriculture, or the first agricultural revolution, which is pretty much the legacy that you carry on has done to change humans and human society. So an age of disruption, but again, an age of disruption which you, as food producers, as people working in agriculture, are so well primed for. Because you've done this already multiple times, right? If you look at the Neolithic revolution 10,000 years ago, or from 10,000 BC, where we moved from being hunter-gatherers to subsistence farmers, to then the second agricultural revolution, where a lot of technology allowed us to lead less workers on farms. Lots of people moved into cities and started working to factories, to even the revolutions we've seen in the 20th century, which has allowed the yields to go up exponentially and subsequently the world population to grow. And now we stand at another point like this, right, where the challenges are great because more food production is needed than ever with the burgeoning population of the world, but also it needs to be done with sustainability in mind as we reach kind of the limits of what the Earth's environment is capable of. So huge challenges ahead, but also huge opportunities. And I think that AI is going to be an integral part of ensuring you can make that transition, which you've made so many times already in the past. And I guess the final thing to end on is that ultimately, because of this being so philosophical and ultimately coming down to, again, this core question of intelligence, which we've always assumed to be a unique human trait, this is much bigger than just one industry, right? It fundamentally hits on the question of what does it mean to be human? And there was a really interesting podcast released, Steve Jobs and Joe Rogan, before his death, where they were discussing exactly this point where we find ourselves at. So let's have a listen.
It will be interesting to see what happens when you have computers that are as smart as people, but much more reliable. They won't get tired, they won't get sick, they won't go on vacation and leave work unfinished. You tell them to do something, they'll just do it. And they will have many more orders of intelligence than people have. The computer will be 1,000 times more important than it is today. We're right on the edge of that. So what do we want to do about it? Do we want to just ride the wave or do something else?
It kind of scares me, to be honest.
It should scare you. But it is also really cool.
So kind of scary, but also really, really cool. And in the plot twist that no one saw coming, that is obviously an entirely AI-generated video. That conversation never took place. Thank you so much for having me.